Long before steel pipelines carved across continents and compressor stations hummed beneath the earth, an ancient civilization was moving natural gas across entire landscapes, using nothing more than bamboo, clay, and pressure. No turbines, no diesel engines, no electricity. Just gravity, geology, and a deep understanding of how fluids behave under confinement. This is the story of the bamboo natural gas pipelines of ancient China, an industrial system so sophisticated that it would not be replicated in Europe for nearly 2,000 years. To understand how this was possible, we have to travel to the Sichuan Basin in what is now southwestern China. This region sits atop rich deposits of both brine and natural gas. For more than 2 millennia, communities there were extracting salt from deep underground brine aquifers. Salt was not simply a seasoning, it was a strategic resource, essential for food preservation, trade, taxation, and military logistics. By the time of the Han Dynasty, Chinese engineers had already begun drilling deep wells using percussion techniques. They used heavy iron drill bits suspended from bamboo cables to repeatedly strike the earth, gradually pulverizing rock and reaching depths that astonished later European observers. Some of these wells extended hundreds of meters underground, tapping brine reservoirs under immense natural pressure. But something else came up with the brine: natural gas. At first, this gas was an inconvenience. It was volatile and flammable. It escaped from wells in violent bursts and occasionally ignited. However, instead of treating it as a hazard, engineers in Sichuan recognized it as a fuel source. Rather than venting or flaring the gas wastefully, they devised a way to capture it and move it across distance. And this is where bamboo enters the story. Bamboo is not simply a plant. Structurally, it is one of the most efficient natural materials on Earth. It grows in segmented hollow tubes with remarkable tensile strength and natural internal smoothness. Each stalk is divided by nodes, but when carefully cut and joined end to end, it forms an elongated conduit capable of transporting fluids or gases. Ancient Chinese engineers exploited this design. They cut mature bamboo stalks, removed internal partitions, sealed the joints with natural resins and lime-based compounds, and bound the segments together. The result was a flexible, lightweight pipeline. These bamboo pipes were then elevated on wooden frames or buried shallowly underground, running from gas-emitting salt wells to evaporation facilities miles away. The critical question is this: how did the gas move without pumps? The answer lies in pressure differentials. Natural gas trapped in subterranean reservoirs exists under high pressure. When a well penetrates such a reservoir, the gas naturally expands upward toward areas of lower pressure. If the wellhead is properly sealed and connected to a closed pipeline, the pressure within the reservoir becomes the driving force. In modern systems, compressor stations maintain this pressure across long distances. In ancient Sichuan, the geology did most of the work. The salt wells were often artesian, meaning the internal pressure was sufficient to push fluids and gases to the surface without mechanical lifting. Engineers used this naturally pressurized gas as a continuous energy stream. Once captured in sealed bamboo pipelines, the gas flowed toward lower pressure endpoints, where it was directed into clay or iron burners beneath large brine pans. At the evaporation sites, enormous iron cauldrons boiled brine for hours, sometimes days, to crystallize salt. Before gas integration, this process relied heavily on wood fuel. Deforestation became a serious issue in certain regions. By diverting natural gas to the brine pans, salt producers dramatically reduced wood consumption. This was not a small experimental installation. Historical records from later dynasties describe extensive networks of bamboo pipelines spanning several kilometers. During the Song dynasty, documentation indicates that entire salt fields were supplied by centralized gas wells. Some accounts from the Ming period describe thousands of brine wells operating in the Sichuan Basin, with complex distribution systems channeling gas to multiple evaporation furnaces simultaneously. The system required valves, pressure control, and maintenance crews. Workers monitored leaks, replaced damaged bamboo sections, and managed flow rates. In effect, this was an early industrial energy grid. To appreciate the sophistication of this system, Consider the engineering challenges. Gas leaks are dangerous. Natural gas is invisible and highly flammable. The joints between bamboo segments had to be carefully sealed to prevent pressure loss and accidental ignition. Clay sleeves reinforced connection points. Iron collars were occasionally used where pressure was highest. Some systems included primitive one-way valves carved from wood to regulate direction of flow. There is evidence that gas was even separated from brine at the wellhead using specialized fittings, allowing operators to route brine downward through one conduit while directing gas into another. European natural gas distribution did not begin in earnest until the 19th century, when coal gas networks were installed in cities like London. Meanwhile, China had already been transporting natural gas through plant-based pipelines nearly 2,000 years earlier. This was not a coincidence. It was the result of a cultural emphasis on hydraulic engineering and resource efficiency. Chinese civilization had long mastered canal systems, flood control, and irrigation networks. Applying similar principles to subterranean energy was a logical extension. Modern infrastructure is dominated by steel, concrete, and petrochemicals. Ancient Sichuan engineers built a high-pressure gas transport system from grass. Bamboo regenerated quickly. It required no smelting, no blast furnaces, and no fossil-fueled manufacturing plants. When a pipe section degraded, it was replaced locally. The system was decentralized yet coordinated. Wells operated semi-independently, but distribution networks allowed gas to be shared among multiple production sites. Labor was specialized. Some workers drilled wells, others maintained pipelines, others oversaw evaporation furnaces. This division of labor mirrors modern industrial organization. Yet there were limitations. Bamboo pipelines could not withstand extremely high pressures indefinitely. Over long distances, friction and minor leaks reduced flow efficiency. Weathering degraded exposed sections. Maintenance was constant. However, the system endured for centuries because it was adapted to local geology and resource availability. It was not over-engineered. It was precisely engineered for context. When Western observers eventually encountered Chinese salt operations in the 17th and 18th centuries, they were astonished by the scale of drilling technology alone. Reports described wells over 500 meters deep, drilled using techniques that would not appear in Europe until much later. The integration of gas capture and distribution added another layer of complexity. The bamboo gas network demonstrates a crucial principle of energetics. Energy does not need to be manufactured if it can be redirected. The pressure already existed underground. The engineers did not create force, they guided it. This philosophy is visible across many ancient systems. Roman aqueducts used gravity instead of pumps. Persian wind catchers cooled buildings without compressors. In Sichuan, geological pressure moved fuel without turbines. It is tempting to frame this story as lost knowledge, but that would be misleading. The knowledge was never entirely lost. Salt production in Sichuan continued into the modern era. What changed was the material base of infrastructure. Steel pipelines eventually replaced bamboo. Industrial drilling equipment replaced percussion rigs. However, the conceptual breakthrough had already occurred. Natural gas could be treated not as an unpredictable hazard, but as a transportable utility. This realization predates modern energy corporations, modern fossil fuel geopolitics, and modern pipeline networks by millennia. When we look at today's global gas infrastructure, stretching thousands of kilometers across continents, powered by compressor stations and monitored by satellites, it appears impossibly complex. Yet at its foundation lies a simple physical principle that ancient Sichuan engineers understood intuitively. Gas flows from high pressure to low pressure when given a path. The brilliance was not in inventing pressure, but in building the path. And that path was made of bamboo. The story of these pipelines challenges the assumption that advanced infrastructure requires advanced materials. It suggests that intelligence, context awareness, and careful observation of natural forces can substitute for brute mechanical power. It also reframes how we think about industrial history. The first energy grids were not coal-fired power plants. They were not steam engines. They were decentralized networks of wells, pipes and furnaces built from organic materials and powered by the physics of the earth itself. In an age increasingly concerned with sustainability and regenerative materials, there is something quietly radical about a civilization that transported fossil fuel through biodegradable conduits grown from soil. The bamboo pipeline system of ancient Sichuan was not primitive, it was elegant. It harnessed geology without overcomplicating it. It distributed energy without combustion engines. It industrialized salt production without stripping forests bare. And it did so nearly 2,000 years before the modern gas industry would claim innovation. When we speak about technological progress, we often imagine a straight line from primitive to advanced. The bamboo pipelines disrupt that narrative. They reveal a parallel lineage of development, one rooted in material efficiency, local adaptation, and deep understanding of natural systems. The next time you see a modern pipeline stretching across a desert or under an ocean, remember that long before steel welded itself into a global grid, bamboo once carried flame across the Sichuan Basin. If you enjoyed this video, don't forget to like and subscribe so we can keep improving the channel. See you next time.